Okay, so let's look at this. I erased something here. It was on the preceding video, so you can accuse me of anything you want. There's still an error here that I'll fix when I get to it. Just a sign error, but just a sign error. That's what makes the world deteriorate if you're not careful. Okay, y double prime plus 3y equals e to the negative 3t. The homogeneous equation, you're going to get 0. We're going to solve the homogeneous equation, and we get the fundamental set sine of square root of 3t, cosine square root of 3t. So that our Wronskian-like matrix, Wronskian's actually determinate, but the matrix, very similar to the matrix we take, the matrix we take the determinant of to get the Wronskian, is going to be just this. Okay, y1, y2, sine and cosine of square root of 3t. y1 prime, y2 prime. In each case you get a square root of 3 from this chain rule. And the derivative of the sine is the cosine, derivative of the cosine is the negative of the sine. Now there is a negative there, and it's clear enough, but these things are kind of bunched up, so let's make sure we point that out and maybe do a little boundary there. Okay? And it easily calculated the determinant here is negative 3. You get negative 3 sine squared here. You get a negative of 3 cosine squared here. Same argument in the sine and the cosine. And that's going to give you square root of 3 times sine squared plus cosine squared, which is negative square root of 3. I'm not sure I said all of that. I'm not sure I said the negative in the previous step, but that's what you get, and that's easy to do. Okay, so we invert this matrix. That means to flip these two and then make these two negative, right? So we flip these two, we get the negative 3 sine 3t, and we get the sine 3t. Now you see from the erasures that I've got sines and cosines backwards. Again, it was one of those days. I was fine with the procedure, but the details just weren't going to come. And then we changed the signs of these, except I only changed the sign of this. I didn't change the sign of this. So I need to change that sign and make that negative. Okay. Now we have what I think is a correct inverse matrix. So and I haven't written down the form of this thing, but it's u1 prime, u2 prime, equals, yeah. I'm still doing it a little bit. Wait, I'm supposed to write something else down. But it's this matrix, the inverse. And I'm going to go ahead and divide by negative square root of 3. You'll let me do that. No, let me do that and hold your breath to see if I do it right. We have sine of the square root of 3t, cosine, no, see, already. Doing something wrong because, of course, we don't have a square root of 3 in front of this. So we're going to get square root of 3 over 3, cosine of the square root of 3t. And here then, we're going to get cosine of the square root of 3t and negative square root of 3 over 3 sine of square root of 3t. Now read that carefully. Unfortunately, you can't let me know if I did that wrong. Okay, and we multiply that by our 0 g of t being e to the negative 3t. Looking twice to make sure it's not a negative or something. Okay? Now, at this stage, that's all I'm going to do, because you just go ahead and do what we do. We find that u1 prime is e to the negative 3t times a multiple of the cosine of the square root of 3t. Well, that's just an exponential times a cosine. We already saw an integration by parts previously that involved an exponential and a cosine. And we just do the same thing. And here you're going to have the exponential times a multiple of the sine, and you just do that carefully, and you get your solution. And of course, we can figure out what our solution would have to be, because y double prime and 3y, well, the only way you're going to get a multiple of e to the negative 3t is for y to be a multiple of e to the negative 3t. There's nothing else whose derivatives will give you multiples of negative 3t. So let's just do that real quickly and see how this should come out. Let y equal a e to the negative 3t, then our equation becomes, well, y double prime is going to be 9a e to the negative 3t, and then we have 3a e to the negative 3t equals e to the negative 3t. Now at that point you can just about do it by visually. Obviously a is going to have to be 1/12, but if you don't see that, you see, well, divide out the e to the negative 3t, 9a plus 3a equals 1, a equals 1/12, so that your particular solution y, 1/12, see what I'm talking about, 1/12 e to the negative 3t. When you find your u1 and u2 by integration and add them up, it's going to simplify to that.